Hooray! Today, we're finishing a series of conversation about basic relationships in geometry. We will focus on angle bisector and the correct way of communicating about relationships formed by it. Think of an angle, perhaps an angle like my STA. Let's cut this angle through its interior and vertex T using a subset of a line, such as ray TR. But we will do it in a very special way. We will make sure that the two parts formed by TR are angles equal in measure, angles who are congruent. This will give us an opportunity to state a special name assigned to such ray TR. In geometry, we call it an angle bisector. So it is a subset of a line or a line itself that cuts an original given angle into two congruent parts, two congruent angles. Once you've established that you have an angle bisector, you have to identify on your diagram the two congruent angles. And the way we do it is by using the same number of curves identifying each of these congruent angles. The common sense will tell us that since these two angles are equal in measure, then 1/2 is said to be congruent to the other half. This is a verbal expression of the relationship formed by an angle bisector that in its turn forms two congruent angles who are halves of the same whole. We now will be able to write this relationship in symbols of geometry, given a name to each of these halves. We will identify half on top, angle STR, as 4a plus 5, and half on the bottom as 6a plus 3. You might be surprised to see that these expressions do not look the same. That is common. You have to remember that expressions themselves are sort of a disguise for the numerical values of these two angles, who must be equal. Understanding that will allow us to write the fact that angle STR, the one on top, is equal to angle ATR, the one on the bottom. And then we will continue with the substitution of algebraic expressions that represent these halves. Once you solve this equation, the value of A could be substituted into each of these halves to find the numerical value. But here is the thing. You see, not always when you have an angle bisector and understand that you have two congruent angles, not always that is that you would have expressions or values that represent those halves. Consider this situation. At first sight, it is the same as the previous one, but then realize that I'm not given the second half. Instead, I am given the value of the entire angle. You are absolutely right thinking that 1/2 is still the same value as the other. But the problem is that if I use the same relationship and substitute 4a plus 5 to the left and 4a plus 5 to the right, then I will receive an equation where left actually will equal the right, and such equation cannot be solved. That's where we run into a problem. So we have to find another way to rewrite these relationships that would also make sense. And what would be helpful here is the fact that these are still parts that make the whole. To be precise, it's that half, 4a plus 5, that I could take twice, and it will make the whole. That will save the situation. Because now I could say that I take angle STR twice, remember to multiply it by 2, and will receive my whole angle STA. Substituting the algebraic expressions will also allow me to solve for A and identify the half itself. Now, I hear some curious minds wondering what would happen if I actually took the whole angle and divided it by 2. Wouldn't that, I hear you say, also equal a half? Yes, of course. I absolutely agree. Your whole angle divided by 2 produces exactly the half. And what you just came up with is simply a different way to write the same fact that we worked with a few seconds earlier. In fact, if you take this first expression and divide both left and right side by 2, you will receive exactly the second expression. And frankly, at this point, it would be a matter of taste. I personally prefer to work with doubling rather than with dividing by 2. At this point, it's important to make a connection between this new piece of our puzzle and what we've already learned about segment bisection. And notice all similarities and differences caused by the nature of these situations. It's also important to notice how angle bisector situation is similar and is different with angle partition situation, and even with segment partition situation, because from now on, you will start identifying whether your problem is about angles, and then you will be applying one of the cases below, or the situation is about segments, and then you will be working either with betweenness or maybe bisection. And that is a complete system of our basic relationships between angles, segments, and their parts.